Right, today we're going to be looking at development methodologies, or specifically one known as the traditional method. This is a little bit of a detour from what we were doing in the last few weeks, in that was just kind of the pure theory section, whereas this is actually a little bit of theory that comes before programming. There's not much really, this covers almost all of it. I'm just kind of doing it in a random order because this is what I thought would be good to do at home. So we're going to be covering something called the traditional method, and there is seven stages, and I'm just going to cover what each of these are. But before we even get to that, what is a development methodology? It's something that companies that are filled with programmers, web designers and all that, they will follow to meet projects. So there's a bunch of different ones. Some are quicker and some are a bit slower, but the slower ones have different advantages. We're actually going to be looking at one of the slower ones, which is the traditional method, and we're going to be talking about its advantages and disadvantages. We'll also follow this when we're looking at the coursework, not quite as in-depth as they go, but we'll be doing it at least each of the stages will be covered at least a little bit. So the traditional method, it's sometimes known as the waterfall method, which is important because that actually comes up quite a lot. And it's called the waterfall method because here it is. Each of the stages you can go down, but once you go down, you can't go back up. You can't climb up a waterfall unless you're like a salmon or whatever. So you can't, once you go down, you can't get back up. That's why it's called the waterfall method. Each stage must be completed before the next, and just means that you can't go from this stage to this stage. You can't skip one following this method. And you can't revisit previous stages without restarting the whole process again. So if you found out there was a problem here, for example, usually if you're following this strictly, you have to go all the way back up to the start, and each of these stages can take weeks, if not months, for a company to do. This is an iterative process. Now what that means is you keep going through the process again and again, making it better each time. So each time you get a new iteration of something. So you go through the 7 stages, and then if you get to this, if you get to this bit normally, you find it's not good, then you will go back to the start and you make a new iteration. You make 2.0, then 3.0, and so on. Because it takes so long, and because you have to keep redoing the whole thing, it's best used on smaller projects. Now, what are the advantages of this? It's reliable, and that's only because it's tried and tested. So many people have used it in the past, and it often gets good results. Not always, but it often. And the disadvantage, there's quite a few more of them. Like we said, it's slow. So each of these stages could take weeks or months. It's expensive. Now, how could just following a process be expensive? It's expensive because it's so slow. You have to pay for employees that are making the software or whatever, and that costs a lot of money to fund. It's also inflexible. So we talked about before how if you mess up a stage, you have to go back to the start. It's quite inflexible. You can't. That takes a long time, which is, as we've just said, is slow and it's expensive. So those are the advantages and the disadvantages. In case I haven't said, when we're going through this, I like to imagine that, just because it makes a little bit more sense in my head, if somebody has, they're meeting up with someone and you're trying to make a video game for them, because video games are quite visual and it's a bit easier to picture it that way. But of course, just regular software for any other company is how it's kind of made anyway. So yeah, picture how would a video game company make this. That might help you. So the stages, I've been talking about these different stages, but I haven't actually said what they are. So they are analysis, design, implementation, testing, documentation, evaluation, and maintenance. Now that's quite a lot to remember, so the common way people remember it is with this little saying, "I dance in the dark every Monday," and that is because each letter at the start represents one of the stages. You can feel free to make up one of your own if that's easier, but that's generally the one people go for. So I dance in the dark every Monday. Now on to the actual stages themselves. I've got some great stock images here. So the client is, so the company is going to have an analyst, right? This analyst has to have great social skills. I wish I was joking, but this used to actually be in the old Nat 5 exam. It would say, what qualities does an analyst have to have? And you'd have to say, great social skills, because I don't know, I guess programmers are socially awkward. So, but an analyst with great social skills will meet with a client, so somebody from another company that they have to build software for. Once they meet, obviously they talk. Something called a software specification is made. This is just a document that is, it outlines what needs to be done, because you can't just make a verbal agreement. That's not trust. You can't just go on trust when lots of money is involved and potentially hundreds of people working on it. It is legally binding, of course, so you have to sign for it. I'm sure lawyers look at it as well. So that is stage one. Stage two is design. There's quite a lot that is done here. As far as we're going to look at it, what you need to know for Nat 5, 4 main designs could be used or could be made. And the idea of making a good design is if you have a clear design, you're going to have an easier time making the program. So the 4 main designs that could be used are pseudocode. Now pseudocode is kind of like half English, half code. We are going to be looking at this throughout the course, and I will teach you how to read this later. User interfaces, now we're not going to be making something as pretty as this, but it's just like if you've got an app, what will it look like? You want to actually draw it out before you start programming it, because you could spend ages programming an app, or spend even longer. I was saying in the previous example, if you programmed a video game, imagine if you just programmed a video game and then at the end your clients, no, it looks pretty ugly, don't like the look of it. You want to make how the user interface is going to look like. So and obviously if it's video games, it's not just user interfaces you're going to be doing. It's going to be like the background art, like all the concept art and that type of stuff as well, but we're not covering that in Nat 5, but it is done at the design stage. If it's a video game, they're going to design concept art and all these like level design and all this type of stuff. But we're interested in pseudocode and user interfaces, and from a programming perspective, we're also interested in flowcharts. This is something again we'll look at later. It does the same thing as pseudocode really, it's demonstrated in a different way. And then we're also looking at structure diagrams, again similar to flowcharts, except rather than having the flow of the program, it breaks down problems. Knowing what each of these do isn't too much of an issue at this point. You just need to know that they are flowcharts, structure diagrams, pseudocode and user interfaces. Implementation, this is the easiest stage to remember. It's just the programming bit. So they've made a design. What do they do next? They use that design to make a program. And as I said before, the better the design, the better the program you should have in theory. After the program is made, it's time to test it. So there are 3 types of test data: normal, extreme and exceptional. Now I put these bits in bold so they stand out. Normal is inside the boundaries, extreme is on the boundaries, and exceptional is out of the boundaries. Now what does that actually mean? Say we have a program that asks for a number between 1 and 10, right? So just a standard program, and it says, hello, please enter a number between 1 and 10. If you wanted to do a normal test to it, you pick any number in between 1 and 10, so any of these numbers will do. If you wanted to do it so they are inside the boundaries are 1 and 10. if you want to do an extreme test, you would do it on the boundaries. So I just said they are 1 and 10. 1 and 10 are your extreme tests. Exceptional is anything outside the boundary. So what's outside 1 and 10? So you can go less than 1 and get 0. You can go more than 10 and get 11. You can go much higher than 11. So we've got 11, 0, 5,000. Really doesn't matter how big the number is. And then you've got just dog. Any word is actually exceptional. If you type in a word, that is way outside the boundaries of 1 and 10. You can also do negative numbers, just the space bar, see what happens. Just nothing, don't type in anything, just press enter, see what happens. All of these are exceptional tests. You want to get in your head the difference between extreme and exceptional. I used to get confused because to me, extreme means more than exceptional, but I guess it's like pushing it to its limits, pushing it to the extreme. And if you do something exceptional, like if you do exceptional on a test, it normally means you go above and beyond what you're meant to do. And exceptional, although exceptional is kind of like bad for your program, it's above and beyond what it's meant to do, and see how it reacts. Because you never know, sometimes you can actually do an exceptional test and it might still work, which isn't necessarily bad, but you want to test it just in case. Right, documentation. There's 2 documents made at this stage. The first one is the user guide. This is just how to use the program. Now, there is actually, it could be a physical document, it could just be a Word document. The reason I've put this screenshot here is just having like the help in PowerPoint or Microsoft Word or whatever, that is technically a user guide. If you can search it, like even if you can search what you're looking for, even though it's awful, normally it's still technically a user guide. The technical guide is how to install the program. I know this sounds kind of weird because normally you just like download the program and that's it, but you have to think, like say the school got a new program, it wouldn't just be as easy as downloading it and installing it. You'd have to give it to the computer technician and they would be given a specific guide on how to install it to every computer in the school. So how to install the programs there. Also the PC requirements, and this could just be like, honestly, like if you go on Steam or whatever and you look at the system requirements, like the type of processor you need for your computer, that counts as a technical guide, or at least it's part of the technical guide as well. So those are the 2 documents made at this stage. The evaluation stage is important because the analyst, the not socially awkward analyst, will meet up with the client again at their evaluation stage, and basically they say, this is our finished product, and what do you think? And they check if it is fit for purpose. Now, fit for purpose means, does it do what it is meant to do? Now, this term is important because in your coursework at the end of the year it will say, is your software fit for purpose? And it won't explain what that means, but it just means, does it do what it is meant to do? Sometimes you get exam questions that says, is this fit for purpose? And the way it'll be phrased is like, this program wants to do blah blah blah, and it gives you a bit of code and you say, is it fit for purpose? Now, if it doesn't do what the question wants, you say no, and then you explain why. So if this stage is unsuccessful, like I said at the start, it's an iterative process. You need to start a new iteration and you go right back to the analysis stage, and you have to sit with the client and say, right, we made this piece of software, we made this game, it's not how you expected it to turn out, what can we change about the game? And then you have to go back to the design, you have to make your user interfaces, your pseudocode and that. If it was a game, you make your art, your level design and all that type of stuff. Then you program it again, although you'll have some program to build off, and you go and then you have to keep testing it and so on. Now it is a bit weird why we go back here, like we start going back in the second last stage, and that's because maintenance is a bit of a weird one. This can happen later, up to years later. This is when you've released your software and you need some fixes. So maybe you release it to the company and you didn't pick it up in your testing, but the people using your system have realized, you know what, this doesn't actually work, or there's like a little bug or whatever, you need to get rid of it. So the maintenance stage will get rid of bug fixes. Normally this is paid for in advance. So when a company get software made for them, the bug fixes should be free. Same with if you have a video game and it has bugs in it, you don't expect to pay for the patch that gets rid of the bugs. It should be free. Now, new features added, if the company decided, right, we want to add more features, that's not going to be free. Same with, actually this holds up with a video game. So if a video game has bugs, you don't have to pay for it, you get a patch. But if you want new content for your video game, you have to pay for it. That is DLC. And the last one is adaptive maintenance. So this doesn't always happen, but they might agree with like the software company that say like, right, if Windows 10 jumps to Windows 11, will you upgrade our Windows? Like, they normally have that out in writing beforehand. And normally I think that's done for free as well. Yeah, it should be. And that is everything really. I know it was quite a lot. Hopefully this explains some of the processes. You just need a basic understanding of each stage and the order that they come in really, and obviously the advantages and disadvantages. Right, there is just again another short little quiz. Thank you for listening, and please follow me on Twitch for my live streams at the weekend. Right, thank you, bye.